All right, so EV5 brings together EV2 and EV4 into one single idea, which is this idea of a basis. A basis is a set of vectors, which we've been given above, and that set of vectors needs to do two things, or two things need to be true about it. It needs to span whatever we're talking about, so in this case, R4. So that brings us back to EV2, and it needs to be linearly independent. Each of those vectors needs to be linearly independent from the other vectors, which is our EV4. Yes, so space is EV3. And so we already know how to find these things or check these things once we have our reduced or echelon form of that corresponding matrix made from those vectors set as our columns. We need to have the number of pivots equal the number of rows to have span, and we need our number of pivots to equal our number of columns to have linear independence. As we know, our rows are going to be determined by whatever the heck we are in here, so R4. So pivots, we need to have exactly 4 of them, 4 rows or columns. So our matrix needs to be 4 by 4 to begin with, and then it needs to, when we do the RREF, do exactly what we see in this first particular example. It needs to make that identity matrix. So in this case, we can say yes, the set forms a basis for R4. Now, I wanted you to not only answer the question, which we've done, so we've got our conclusion, check, but what's been met and what about this matrix made those decisions. So basically the two things I wrote up above, because the vectors span R4, number of pivots, 4 equals number of rows, 4, and the vectors are linearly independent. Number of pivots equals number of columns. So I really like the way this answer is written currently, because not only do I have the properties that are met by talking about span and linear independence, but I'm giving right behind them the link. So it's not left up to the reader to assume you know what you're talking about when you then say the number of rows is equal to the number of pivots, and you haven't made it clear which of those two properties are being satisfied with that particular situation in that matrix. Yeah, so there you go. That was what we were looking for in number 1.